Hi, this is part 2 in our little series about common problems with porous surface materials. Today we're going to talk about spalling. It's a funny word, spalling. It just basically means when you have a situation where little bits, where it looks like the material's starting to corrode. Here's a picture of it. Now this sort of damage doesn't just happen, you don't get big, it looks like big chunks have been eaten out of the material, but that's not how it actually happens. It starts on a very microscopic level. If you remember in number 1 in our series we talked about efflorescence. So efflorescence happens when you have, well, the water we have on the planet and in the earth underneath your pavers and all that is not pure. It contains dissolved minerals in it. And water will always make its way back to the top surface of a material as it dries out. Water always wants to go from wetter places to drier areas. So what will happen is maybe it rains and the water lands on your paving, and now the area underneath is drier. The area on the top now is very wet because the rain's landing on it, so it'll be sucked down towards the dry material. Then the sun will come out, the rain will stop, the top surface will dry out, and as it dries out, that now becomes the driest part of the surface, and the water gets sucked back up from underneath to that dry part of the surface. The problem is, as it's travelled through maybe your concrete paver and the mortar underneath and maybe earth underneath that, it's picked up all sorts of dissolvable minerals along the way, even more than it had when it landed. And now, when it comes up to the top, it evaporates and leaves those particles behind. As we saw before, it can leave them on the surface as what we call efflorescence. But even more difficult problem and more important problem is spalling. So if it leaves those little mineral crystals, tiny little mineral crystals just below the surface, so the water evaporates and leaves them behind in the pores, those little crystals, as more and more water with that mineral dissolved in it goes through, those little crystals will actually grow. And as they grow, they'll break off tiny little bits of the material near the surface. And at first you won't even see them. We call that micro-spalling. And you get these tiny little pieces breaking off. Of course, as that happens, it means those little pores are becoming bigger and bigger, and more and more water flow going through, and more of the minerals being deposited and growing, because as the water flows faster, that accelerates the whole process, and bigger crystals growing and breaking bigger pieces off, and the material slowly becomes weakened, and eventually you get whole pieces coming off. But it doesn't usually happen in the beginning. It usually gets weakened, and a lot of micro-spalling happens. Millions and millions and millions of little particles come off. You might see, for instance, if you've got a saltwater pool, you might notice just what looks like a little bit of sand in the bottom of your pool. Now, it could be sand, or it could be just little bits of your grit from your paver that are breaking off, that are spalling from the salt that's in the salt water in your pool. Now, there's another way spalling can occur as well, and it looks identical to salt spalling. And this is if you happen to live in a part of the world where you get below freezing temperatures. So if water gets into your material, it could be a cladding on a building or a paving or whatever it is, and freezes, we all know that when water freezes, it expands. Now what happens is, so if you get water like those little salt crystals and it's close enough to the surface of the stone, just below the surface, in the little pore there, and it grows and it expands when it freezes, it will break tiny little microscopic bits of the stone or your paver or whatever off. And again, as the pores get bigger, because these little bits are breaking off and there's more water in there, it expands even more when it freezes, and bigger bits break off, and ever larger amounts of your material start corroding and falling off. And so the answer to this is, of course, water is the basic underlying problem. If you can get water to stop moving anywhere near that surface area of the product, of your stone or your tile or your whatever porous surface material it is, then you stop spalling from happening. If there's no salt water or no water that's going to freeze anywhere near the surface, that spalling can't happen. So to do this, you need a technology, you need a special kind of impregnating sealer, not just any one, but that'll actually penetrate far enough into the material. And that's the whole point of dry treats technology. Our little sealing molecules are literally 400 to 500 times smaller than other impregnating sealers. And they'll go in and create a really deep water repellent barrier in the material. So you want to go in very deep, and that whole area becomes water repellent, and then the water can't actually make it anywhere near the visible surface, carrying the minerals or where it can freeze and spore little pieces off. So yeah, that's the answer. Prevention is better than the cure. Once it happens, it can either be very difficult to fix or impossible if your material's too corroded. You just have to tear it out. So prevention is definitely better than the cure.